Okay, this video is going to take you through the notes on logical operators. And so as we look at this, we see that there are three logical operators. And those are you have the double ampersand, which is the AND operator. You have the double pipe symbol, which is the pipe symbol is above the enter key on your keyboard. This is the OR operator, and then the exclamation point is the NOT operator. And so what we do is we're going to be using the AND and OR operators that allow you to combine what we call two Boolean expressions into a single expression. So what's this Boolean expression stuff? Okay, first of all, there's a thing called Boolean values. The Boolean values are either true or false. So, for example, you have int age is assigned 15, and 15 is an int value. Okay, and there's how many int values? There's an infinite number. And so now you have a Boolean value. Well, Boolean can be a data type, and let's just give the name of the variable choice, and we can assign it to be true with a lowercase t, or we could assign it to be false. And that's the only two values that there are that are called Boolean values, and that's how the computer makes decisions based on whether things are true or false. And notice there are also no quotation marks, because this is not a string. It's a Boolean value. There's just two of them, true and false. A Boolean expression is what we've been calling a condition. So if, and then num1 is greater than or equal to 10, the num1 is greater than or equal to 10 is the Boolean expression. That's a term that we'll be using as long as this is also called the condition. This is the condition that's being tested or evaluated. All right, so using the AND or the OR symbols creates a compound Boolean expression. So creates a compound Boolean expression. And let me see here. I don't know how this happens. And then now, so regular Boolean expression is num1 is greater than or equal to 25. A compound has two of them. You have num1 is greater than or equal to 25, or num2 is equal to 15. That is a compound Boolean expression. Now let's take a look at the AND operator first. The AND operator, in a real life example, and the thing to consider here, this is actually fairly simple, so I'm going to try not to complicate this. We know what AND means. If I asked you this, I tell my daughter, if you wash the dishes and take out the trash, I'll take you to Dairy Queen. So she proceeds to wash the dishes, and then she says she's ready to go to Dairy Queen. Well, do I take her to Dairy Queen? Hopefully you realize no, and the reason is because she didn't do both tasks, and that's exactly what happens here with the AND logical operator. So here it is in kind of a Java pseudocode type situation. Kara does the dishes and Kara takes out the trash. She does the one, but she doesn't do the other. And so that's false, and so we will then we will ignore this. We won't go to Dairy Queen, and I'll tell Kara, I need you to do both tasks that I asked you to do because it's an AND. So the bottom line is both Boolean expressions must be true in order for an AND compound expression to be true. Just one false produces a false and compound false and compound expression. Okay, so what I need you to do is practice these here on number 6 on page 8 here, and a good practice is to put the values, write the values above the top of these, and then evaluate things from there. So go ahead and do that, and then check back to see how you did on the answers. All right, so if we come back and look at this, then we see that 12 is greater than 5, and 12 is greater than 4, and so both are true, so the whole thing is true. And then on B, we have x, let's see, 12 is, well, you got to do the z times 3, so this is 12 here. And then, so 12 is equal to 12, so this is true. And then 5, is that equal to 8, which it is not. And so that is false. And so, therefore, this whole thing is false. And then on the last one, you have 5 is less than 4, which is false. And then you have 5 is less than or equal to 12, which is true. And so the whole thing is false because both need to be true. Now, what is short circuit evaluation? And this is when the compiler, let's see, how can I put this? After the compiler evaluates the first Boolean expression, it knows the value of the compound Boolean expression. Short circuit evaluation means the compiler doesn't need to evaluate the second Boolean expression, or we could say even condition. If you want to say just condition is another way to say the same thing. All right, and so which of these did that? And that would be the C, because once it saw that the first one's false, and since both have to be true, it doesn't even have to check the second one. It knows that this whole thing is going to be false. All right, so that's short circuit evaluation. All right, and then let's go, here's just an example that you can look at. We're not going to go through this in the video here, but this is an example where if you were to trace this, you would see that you have two choices here, and you can see how the compiler would operate with this. Let's go ahead and go to the OR operator. The OR operator, if I tell my daughter, if you wash the dishes or take out the trash, then we can go to Dairy Queen. Okay, so she proceeds to wash the dishes and then says she's ready. So it's the same scenario, only this time I said or. And do I take her to Dairy Queen? Why, yes, I do, because she did at least one of the tasks, and so we understand that already. And so here's this, you have the pseudo code down here, which we're not going to go through, but you can just see how that operates. And then we have the bottom line, which is an OR compound expression is true as long as at least one of the Boolean expressions is true, otherwise it's false. So just one has to be true. So go ahead and evaluate the problems in 10 to practice, and then we'll take a look and see how you did. Okay, so let's take a look at these. So we have 12 is less than 5, which is false, and so it needs to check to see if the other one is true, which it is. 12 is greater than 4, so the whole thing is true for A. In B, then, is 12 equal to 4 times 3? And yes, it is. And so this is true. Now, this using short circuit evaluation, we don't need to look at this because we already know that the whole expression is going to be true because one is true. Okay, so the whole thing is true. In this one, 5 is not equal to 4. Well, that's true. And so therefore, we do not need to look at this. Again, short circuit evaluation, it's not even necessary to take a look at that. The whole thing is going to be true. All right, so let's go on to the next thing here. This is actual Java code that you can look at and see how that operates if you'd like. The last thing we're going to do is look at the not operator. The not operator is the opposite of the result of the Boolean expression. So not true means false, and not false means true. So go ahead and look at these number 13, do these, and then check back to see how you did. Okay, so let's take a look at this. So in the first one, in A, 12 is less than 5 is false. So somehow I messed up here. Is false, and not false means true. So this thing is considered true. And we look inside here, 5, is that equal to 8, which is false. So again, not false means this whole thing is true. If we look here, we have 5 is less than x, which is false. And then it has an or, so we have to check out the second Boolean expression. Is 5 greater than or equal to 4, which is true. So that means this or compound Boolean expression is true. Okay, but now we're saying it's not true. So the result of this entire thing is false. All right, the order of precedence is the last thing we're going to take a look at. And so all this means is that when you have, when and or are both involved in a line of code there, you do the and first. Do the and first. So here's an example.